And my thanks go, as always, to Luna Lee for providing that lovely intro and outro music for our show. Well, we're back. Yes, CometWatch is not just me now, thankfully. We have a new presenter with us. Would you like to introduce yourself?
John Meitner. I have observatory code W62.
Thank you. And of course, I'm Nick Yvetz, FRAS at 20LUN. So, yeah, we've got a packed show for you. As always, we're going to kick off with the Comets shipping forecast. And we'll go through that. So my thanks, as always, to Nick James and Jonathan Shanklin for their hard work and the BAA's Comet Section page. So latest discoveries and news. 14th of January, discovery of 2025 Y2P pan-stars reported.
Okay, January 14th, Zhang Jiang reports a crux comet in CCORD-1 images.
The 15th, Django Ruan reports 2 Kreutz Group comets in CCOR-1 images.
Zhang Zhu reports a crux comet in CCOR-1 images.
The 17th, Django Ruan reports a Kreutz Group comet in CCOR-1 images.
Zhang Zhu reports 6 Kreutz comets in archive C3 images.
And January the 18th, Django Ruan reports a Kreutz Group comet in C3 images.
I'm going to butcher this name. But McAloy Karzanti reports a Kreutz Group comet in archive CCOR-1 images.
January 20th, discovery of 2025 Y3 pan-stars reported.
January 20th, discovery of 2026 A1 MAPS reported.
January the 20th, Zai Lai reports a Kreutz Group comet in CCOR-1 images.
January 21st, Yang Yu reports a Kreutz Group comet in CCOR-1 images.
January 24th, Nicola Kreitzker reports a Kreutz Group comet in CCOR-1 images.
January 27th, Zhang Yu reports 2 Kreutz comets in CCOR-1 images.
January the 28th, Jago Ru reports a Kreutz Group comet in CCOR-1 images.
January 28th of 2026 B1 P pan-star reported.
January 28th, still discovery of 2026 B2 Sun Gao reported.
January 31st, Zhang Yu reports a Kreutz Group comet in CCOR-1 images.
February the 2nd, Peter Barrett reports a non-group comet in archival C2 images.
February 2nd, Mazu Zhao reports 2 Kreutz Group comets in CCOR-1 images.
February the 3rd, Yasheng Yang reports a Kreutz Group comet in CCOR-1 images.
February 3rd, Zhang Zhu reports a Kreutz Group comet in CCOR-1 images.
February the 4th, Zhayong Ru reports a Kreutz Group comet in CCOR-1 images.
February 7th, Wanshu Blompak reports a Kreutz Group comet in CCOR-1 images.
February the 8th, Jago Ru reports a Kreutz Group comet in CCOR-1 images. So, of course, the website was updated on February the 13th. Normally, as I would say, if there's no recent updates, try the German Comet Group or Seiichi Yoshida's page, which has pretty much everything for Northern and Southern Hemisphere cometary observers for information, or go to the Liga Iberoamericana de Astronomía for observations. Boy, that's a mouthful. So we'll move on to current comet magnitudes and observable region for 2026 February. Now, I am going to mangle this name, so you can all have a good giggle at this one. So
Yeah.
24 E1 Waichos, magnitude 7.5 fade, 25 degrees north to 60 degrees south. When it's visible in the evening. Last visual observations, February 2026.
2025 A6 Lemon, magnitude 9.5, fading, observable from 15 north to 60 south, morning object. Last observed was 2026 February.
24p, Shamus, probably got that wrong. I do apologize. Magnitude 10, fade, 80 degrees north to 50 degrees south is a morning object. Last visually observed 2026 February.
2025 T1 Atlas, 10.5, fading, in conjunction. Last seen 2026 January.
Swan 26b, 11th magnitude question mark, fading question mark, support elongation not yet observed.
Okay. 88p Howe, 13th magnitude, bright, 10 degrees north to 40 degrees south, early morning, not yet observed.
And of course, my favorite comet of all time is the one with the London postal address. 29p, Swashman Wachman, SW1, 13th magnitude question mark, varies, 55 degrees north to 60 degrees south, morning object. Last visually observed January 2026. Before we move on, I will say this is currently a part of a long-term study by Dr. Richard Miles, and he is always glad to receive mono images, luminance images of this comet for photometry purposes.
Okay. 2025 R3 Pan-STARRS, 13.5, bright, observable poor elongation, not yet observed.
2025 N1 3I Atlas, our friendly neighborhood comet that's speeding out of the solar system from somewhere else, going to somewhere else. 13.5 magnitude fade, 80 degrees north to 40 degrees south. It's best in the evening, and it was last observed January 2026.
2026 B2 Sun Yang, magnitude 13.5, fading, observable very poor elongation, not observed yet.
10p Temple, 14th magnitude question mark, bright, 45 degrees north to 45 degrees south. It's a morning object, not yet observed.
2026 A1 MAPS, 14th magnitude, bright, observable 30 degrees north to 60 degrees south, evening, not yet observed.
As always, details are always fully updated at the beginning of this month, but some minor updates may be made more frequently, particularly for the brighter comets. The last partial update was on February the 10th. Now, as always, the magnitude is a rough value for the mean magnitude reported. Some observers will see the comet brighter than this, whilst others always seem to see it fainter. It's the nature of comets. The observable region, as always, is an approximate indication of the latitude at which the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is for the UK, but then if the comet is visible from the UK, like otherwise, the 30 degrees south or the equator is appropriate. The last visual observation is as received by the Comet section of the BAA. Details are often updated on the basis of observations published elsewhere. To be honest, beginners will find it difficult to find comets fainter than about 7th magnitude, and they're going to be difficult to locate. However, on the BAA Comet page, below this information that we're giving you now, there are more information on positions and find a chart. Well, John, it's being a busy year for comets.
It has been a couple busy years for comets, actually.
Yeah, I know that Jen down in Australia has been imaging, and she's been posting some spectacular pictures.
Yeah,
I believe it's of 2024 E1.
Yes.
Her setup is absolutely brilliant. We actually had her on the show many moons ago. We need to get her back. But that's just one of the beautiful comets we've got. 26A1, it's a Kreutz group comet, even though it was discovered quite away from the sun. It is currently a southern hemisphere object. And from all I can see on the notes, it's going to be poorly placed after perihelion. Obviously, unless it becomes very bright, we may not even get it here in Europe. In which case, the period of peak brightness is going to be short. Those with access to suitably located telescopes should make observations, and if they're greater than 9-inch aperture photometric measurements, it is possibly, who knows, could become more active. Swan, well, is yet to make the PCCP, even though Han Jae-tan reported it back in January the 20th, and the amateur astronomy community has derived a good orbit. I really miss Brian Marsden. I have to admit that, because he would sit there with a pencil and paper, and he would work out these orbits, and he would bang it out so quickly once he had a stable orbit. Did you ever deal with any of his work, John?
Yeah, I've read a lot of his work. I actually used to communicate with him when he was alive about some observations. Very, very knowledgeable and great person that we miss a lot here.
Yeah, I believe the old saying was, if it moves or goes bang, Marsden wants to know about it.
Right.
As I say, we've been lucky, I think, in the last couple of years. We've had some decent comets. Nothing like Hyakutake, really. But my favorite, I think, was F1 Swan, because I managed to image that whilst it was, I remote image a lot.
Right.
So I could log into Chile, and I'm trying to remember if Australia was up. I might have imaged it via eye telescope out of Siding Springs as well. But that was an awesome comet. And when it came north, boy, did we know about it.
Mm-hmm, definitely.
I couldn't image it over up here in the UK, but the visual show was something else. So who knows? There's a lot of comets are contrary. We think they're going to be absolutely brilliant, and they fizzle. Sometimes we think they're going to fizzle, and then they put on a brilliant show for us. So we discover.
Definitely.
Now, I've seen your work in the Comet group and CometWatch on Facebook. Could you tell us some more about what you do, John?
What I do?
Yeah.
Besides look for comets and things like that?
Well, you tell us about the astrometry work you do.
Okay. I got really deep in astrometric work probably about 6 years ago, when I started imaging on a regular basis from a relatively Bortle 4 skies. And I started tracking down comets and started imaging and said, oh, well, I know I can submit observations. I just have to go ahead and get myself qualified in an observatory code. So since I got my observatory code, I've continued imaging not just comets, but also recently a lot of NEOs, and I've been actively doing follow-up with those. So it's been a very steep learning curve.
Yeah.
From going from basically knowing nothing to where I'm at today, really.
How would you suggest somebody starts if they're interested in doing it themselves?
What I would suggest is starting with relatively bright asteroids or comets. And first thing, if you want to be able to submit those observations, you'll have to do 6 fairly bright asteroids and 1 NEO, and do that twice, one night and another night. It doesn't have to be consecutive. Report those observations to the Minor Planet Center, and they will generate an observatory code for you. At that point, you can submit your data to them.
Interesting. I know a lot of astronomers have observatory codes, because even when I'm remote imaging, I always put the code of the observatory on my images because it allows. So I know that with the pro-am community, a lot of the professionals see our work, see our imaging,
Right.
and because of by using the observatory code, they can actually then take the image, do data reduction with it, and because they know where it was taken, when it was taken, and the times, and the fact that most of us today are processing fixed files at home, as well as getting very good, clean images directly from the telescope provider, means that they have the ultimate in data integrity. So, what instruments? Okay, what is your setup at your observatory?
Okay. My primary instrument today is a astrophysics um, 350 millimeter f3.8 astrograph. It's fully automated on a go-to mount, and everything's controlled by my observatory here. That's my primary, and I have a secondary instrument is my 180 millimeter astrophysics refractor. It's an f7, also on a go-to mount.
One of the things I've noticed a lot with images is that getting a mount that doesn't have any slip. I noticed that there's a lot of people they when they're buying their mounts now, they're looking for I think it's ones with the smallest periodic error.
Correct.
Right. And I've seen that a really, really diverse selection of mounts. I've seen belt-driven mounts, the traditional gear mounts. What type of mount do you use for your go-to work?
Okay. It's also my main mounts are the National Physics 1600 go-to mount. It's all worm geared. It's sub-arc second tracking.
Yeah.
It's also a very high-end mount, and I've gone through a number of iterations over the years. I've had all types of telescopes. I've had a C8, I've had a C14, a couple of Me telescopes. Unfortunately, their drives were not very good.
Mm.
And when I decided to really get serious, I decided to go for essentially the best I could buy at that point. Obviously, there's others just as good out there, but yeah, I want the minimal amount of work. Most of the time, I don't even have to guide. The telescope tracks just as well as it can. So I could go for hours without guiding.
Well, because I think a lot of people these days they use a camera, a guide camera,
Right,
and they have their main CCD,
right.
CMOS cameras for imaging. In fact, the one I've got is the Zhao planetary cam, because previously I did a lot of I was living in the States where I normally live. It's an urban environment, so for me, I have to go for the brightest objects really, unless I go to a state park. If then I have at least a lot better skies than I do
Yeah,
in the built up.
definitely.
Obviously, the only plus I've got at the moment in my US location is I've got two rivers, one behind me, one in front of me. So that kind of improves seeing
Right.
for imaging a lot better. But even so, I'm still limited because of the light pollution. And it means that, okay, I can't go for the really dark, deep sky objects or the really, really faint comets, but I can still look for the brighter stuff. And if I do visual, well, I don't do much visual work anymore. I wear glasses for everything now. And these are my reading stroke work glasses. I've got a pair for long distance. So it's easier to image and than do visual work. Obviously, a lot of people love to do visual work still, and they get a kick out of sketching comets and stuff. But unfortunately, not for me anymore. I'm trying to think.
Well, I used to do a lot of visual observations. My interest in comets go back to 1965
Mhm.
when Seiichi C came through. I saw that from the center city, Philadelphia, quite easily and very distinctly. And then Comet Bennett back in 70 and West in 75. And from that point on, a number of other comets, including Halley back in 85 and 86.
Oh, I
And
remember that one.
that was spectacular. And we actually did some work. I think it was the summer or August of 85. We visually found Halley's Comet visually in a 24-inch Dobsonian there. And
Mhm.
then in September, I used my C14 to visually observe it. So it's been challenging, but it was certainly a spectacular comet.
Halley was, I think, probably what really got me interested in it, in comets. Um, that and obviously the late Sir Patrick Moore. He was certainly a comet handler aficionado to a greater degree. And I think that we have very few good communicators left
True.
in our particular interest for astronomy. With Patrick gone, we've still got David Levy with us still, thankfully. Um, but we lost Don Machholz a few years ago now, and that was a blow to the community because Don was kind of the guy who helped make it a popular thing. I think really with his podcasts and stuff. Um, but yeah, we are really losing a lot of our really good communicators, and I think that's part of the reason the CometWatch the podcast came around because originally it was called Comet. It was part of Under British Skies, which is on astronomy.fm, and I would do the shipping forecast for comets. It started off as a bit of a tongue-in-cheek thing, and it kind of grew from there. And then it stepped with UBS coming off the air, kind of ported over. Neil Norman said we should do a show. I said, well, yeah. It was kind of like bringing Comet Tales back into existence in a lot of respects, and it's been fun. Um, and I think moving as we are going forward, it's going to be even more fun because we still have some really top notch images and observers with us, and it would be great to get them back on the show. I think
Definitely, definitely.
I really must get back in touch with Terry, see how he's doing and what's going on. I still see him post occasionally in the group, and I know David does. So touch wood, everybody. We will be getting quite a few interesting people back. And it's nice to see Jen really knocking so that's some really excellent images.
Yes, it is.
Can you think of anything else we need to cover for this particular show? Let's see what else we can do. The only other thing I can think of is I'm just trying to see from my notes here. They are talking about 2024 E1 being near its brightest. Have you been able to get any ideas about that, John?
Nothing recently. I haven't done any imaging on it. I think it's too far south, isn't it?
Yeah. Yes.
Yeah,
25
it's too
degrees
way
north.
too far south for me,
Yeah.
unfortunately. But I have imaged it in the past.
And they're thinking it might get to ninth magnitude by the time it hits UK skies. It's already creeping into view for Northern Hemisphere observers, but it's going to be one of those things. And 2025 R3, now that might make sixth magnitude I'm seeing here. There is a
Yeah,
light curve out for it, but
yeah. It might reach 6 magnitude. Like you were saying, the that new Comet C 2026 A1,
yeah,
if it survives, it could be a spectacular comet.
well, that would be really nice.
Yeah.
Let's speculate. Let's speculate. Do you think if it survives, it might either be as good as perhaps Hayataki, or where do you think it would place in the last decades worth of bright comets?
That's hard to say. Certainly, I think it would be potentially like Exeki size back in
Yeah,
'65. Really, that was a sun grazing comet, and this one might do the same thing. But it's very close to the sun, and if it is very close to the sun, maybe before it gets too close, it might flare up
yeah,
to maybe minus 1 or 2 magnitudes and be visible. It's
that
going to
that
be,
that would be nice. Might,
yeah, I think that, but if it does survive,
mm.
it could be very spectacular after the perihelion.
I think that's a lot of the problem is when these comets actually make their passage, their perihelion passage, it then gets very, very iffy about what we're going to get because the sun might kick it into activity, to a huge burst of activity. It can also wipe it out, literally. Um, I remember there was a comet a few years ago. Everybody, oh, yes, this is going to be the comet of the century. And it got wiped out. Ison, so,
Ison, right, right,
and it was wiped out
yeah,
during just as it started its perihelion passage.
right.
Um, it was just one of those things. And the thing we have to keep in mind is the fact that at the moment we are coming down from solar maximum, but there's a lot of controversy around that. Is it really has it peaked or not? So that's a different kettle of fish. And I'm sure there's a lot of heliophysicists and space weather people who some are of the opinion, yeah, we've been at peak solar maximum and now we're coming down. Uh, I think there's a couple out there that say we haven't, but I don't know. I'm of the opinion that I think we are beginning to drop from solar maximum because we're seeing a lot of flare activity. And if you go back, it's kind of like 1972, uh, where the infamous sea mines exploded. I mean, they were magnetic mines and they actually detonated for quite a while. Nobody knew why. There was an X-Flask, there was almost a Carrington event, and the sun, what was coming off the sun, actually triggered them. Now, if there's a comet going through perihelion during a solar flare, I'm not so sure it would survive. But this is speculation because basically we have a G2V yellow dwarf star. It's proven that it can be moderately variable when it wants to, and it's certainly kicking off quite a bit of activity. But it always seems to do that as it comes down from solar maximum. So let's hope that Comet survives perihelion and that the sun gives it a really nice boost.
We can only hope it does.
Oh yeah. But yeah, it's going to be interesting, I think, to see what happens. There was one other thing I wanted to quickly touch on. What was it? I'm just trying to see if I can see it quick enough. Oh, I know what I was going to mention. CCO images. This is news. This is actually new technology that we're able to use. It's kind of replacing the original solar. I can't remember, C3 images.
Right. C3, yeah.
Yeah, and there was another technology that's space probe based technology. I don't, you don't see it anymore mentioned, but what's happened is with the latest GOES not 19 satellite, they have a spectrometer on board pointed at the sun, and it is actually a very good instrument for spotting comets. So the comet community is benefiting from the space weather community in a lot of respects from the technology. The same way that images, we went from hyper sensitizing 35 millimeter films to CCD images, I think, what, 15, 20 years?
About that.
And the technology that gave us our CCD cameras came from the military. They were used on satellites. The CCDs were originally put there on spy-sats to look at the Earth. But as the technology got better, it was declassified effectively. And suddenly the amateur astronomical community could now get cameras that were as good, and sometimes as slightly better than the professional astronomers had at places like Palomar, etc. And the other thing I like to point out is we now have the ability as amateur astronomers to actually take part in professional research into comets, into near-Earth objects, into asteroids. A lot of those asteroids that were originally objects that were classified as asteroids are being found to actually potentially be cometary objects because they're growing. They tend to grow tails, which means technically they're a comet. As they come closer to the sun on their orbit, they're giving off volatile material, or even a dust tail, and they are now beginning to be seen as dead comet nuclei that got stranded in the asteroid belt. So again, there's a big sea change coming in, because originally they were seeing these little spots of light. Oh, it's an asteroid. But suddenly we're discovering they've got tails. So are they comets? Are they asteroids? It's something we can work on with the professional community. The other big thing is we have professional grade telescopes now, and we have the time. The professional community has to book in advance to use the big optical telescopes. They have to book in advance to use the Hubble, where the amateur astronomer can, if it's a clear night, can image from dusk till dawn and provide raw data for the professional community to use. And we get credited on the papers, which is even better. It's an aspect of citizen science, I think, that we never realized we could do until the instruments we had started getting better and better and better. but that's the plus side.
Well, I just got done. Iwan just had a 3-eye atlas campaign where they got a number of amateur astronomers and some professional astronomers to try to improve the astrometry of comets. So we were all, for about 2 months, they were requesting 2 sets of observations using this unique new technique to try to improve the astrometry. So I got my 2 observations in, and about 50 or 60 other amateurs got their astrometry data in. So that will be a published thing out there, and hopefully that will help improve the astrometry of comets in the future. Comet astrometry is not as precise as asteroids, because asteroids you're dealing with a pinpoint piece of light. Comets, you have coma, and finding the actual nucleus is kind of difficult. That's why the residuals are sometimes higher for comets than for asteroids. So that's where, the amateur can always help, hopefully the professionals and just the general gain of knowledge.
Yeah, like I say, our hobby has come a long way from being Victorian gentlemen and their daughters, sisters being a part of their staff, to literally being on the cutting edge. It kind of makes you good. How do I put this? It gives you a good feeling, because at the end of the day, you're helping advance the knowledge about our solar system. Until we can find a way to cheat physics. The famous saying, Captain, I cannot break the laws of physics. Until we can find a way to propel a spacecraft much faster than we can today, and it's slowly coming. We've got ion engines now on space probes, and they are allowing us to explore minor planets. The European Space Agency is building its Cometry Interceptor program, a series of satellites at various Lagrange points. So when a unique comet or a previous target comes in to the inner solar system, they can send a dedicated space probe. They haven't got to worry about launching it. They haven't got to worry about having prior notice, like they would have to if they were going to do it from a scratch mission. When we went to CG, that took years to plan and to build the technology, to launch it, to intercept, and to do the science. We had a very narrow time to do the science at the Comet, CG64, I remember. But with the premise of the ICE missions means as soon as a suitable candidate is coming in, we can nudge the space probe into an intercept orbit and do a lot more science. I remember, one of the reasons I remember Hawley so well is because the company I was working for at that time built 2 of the instruments on Giotto. And those of us who were I think there's 2 of us who were really interested. We were invited into the company boardroom. They had the big screen up, and we were able to watch Giotto intercepting Hawley's comet. Then it went on to Greg Scudder up. Well, a dust particle hit the camera. Everybody said, "Oh, everything's over," but it wasn't. there were instruments on board on Giotto that could still operate, still do science. So then a secondary target had already been allocated potentially, and we went to it. And I think that was part of the building blocks that led to Rosetta, and what we know today. And we've got SLS scheduled, I think it's March, for a manned circumlunar trip still. So we are slowly going back to being not stuck in low Earth orbit. Of course, my favorite recollection of Comet West was when it was being observed by Skylab.
Right.
And this is, someone's going to say, oh, but you called it something else in the previous show. Yes, I did. I got it confused with Kohoutek's comet in a past show. It happens. But anyway, Comet West was due to be observed by Skylab. And I think in a lot of respects, that really helped interest in cometary science, particularly in the amateur astronomy community. The fact that we could use a space station and observe a comet close up. So touch wood, once we get out of low Earth orbit and we go back to high Earth orbit and beyond, maybe we will have the chance to, who knows, send a manned mission eventually to a comet. It's probably going to have to come very close to inside the, at least inside the Martian orbit, for that to be feasible. But Orion, when it was designed to go to Mars as part of a Mars spacecraft. So we shall see. I would love to see manned exploration of a comet. Obviously, it has its risks, because particularly if the nucleus goes active, and if it's that close in, it should be very active. But we can still get instruments close enough to use human decision making in real time. Time will tell, I think, but we are at least hopefully going to see what happens. And obviously, we've had spectacular comet pictures from Mars too, from the landers. There was one comet that came very close, that I believe was imaged in the ultraviolet from Mars. So it's amazing what we can do.
Truly is, and it's only going to get better, we hope.
Well, yeah. I think that with the fact that we are beginning to get back to how the solar system was formed, and comets are a crucial part of the puzzle. They're the most ancient parts of our solar system. They're relatively speaking unsullied. All right, quite a few of them have been in and out of the inner solar system a few times, but there are so many comets out there in the Oort cloud and the Kuiper belt, which could be looked at before they cross the orbit of Neptune and start to switch on. In fact, I know that when we have previously discussed on the show, using an ICE type probe to go to 29p. That would be a good target, because it's one we know very well. We've got used to timing the outbursts of the comet. So
Yeah, I would love to see a probe go to 29P. That would be very interesting, especially if you can put one like in orbit. That's would be even
Yeah.
nicer. You know, it
Well,
might be a
yeah,
very extended orbit, but just to keep an eye and see what is actually happening over a period of time with the activity and where the activity is occurring.
yeah, it's probably one of the best candidates we've got for a long-term comet mission. Um, CG was a fast-moving comet, and we had limited time to intercept it, do the science before it headed outwards. But 29P is a Centaur, as I remember correctly,
Correct, Centaur.
and it's trapped in an orbit around Jupiter. So it's relatively close, and it's like I said, it's one we have an awful lot of knowledge about. We can profile it to the point where we can decide how close the probe needs to get in reality to see what's happening in the comet. So yeah, it would be I think it would be the perfect time to say, yeah, okay, we know we can intercept them now, and let's use a comet that's relatively close to Earth, especially for communications between us and the probe, because that's another big problem. Time lapse. So yeah, let's see what the future brings, eh, John?
Yeah, let's hope that somebody, either the Americans or the Brits or even China, hopefully some of those countries would put some type of probe together and go to 29P would be fantastic.
Well, we've done international missions before.
Right.
Various countries have built various instruments, and then they've either been launched by the European Space Agency or by NASA. So it is not beyond our capability. Hang on, someone. Sorry about that. Someone was trying to call me. But yeah, we've done at work. We've built landers for Mars, which have been international in scope. So we know we can do it. It's just a case of getting the job done and picking the target. As you said, I'd love it to be 29P. We've been going for 50 minutes, John. I think we better wrap.
Sounds like a wrap here at this point.
It's it's been brilliant having somebody to talk to whilst I'm doing it again, and having someone to put stuff in. So anyway, we're going to wrap the show.
Good.
The show
Thank you.
will be up tomorrow afternoon,
Okay.
and we'll get it out there. So it's good night from me.
Good night and clear skies to everybody.
7-3 and clear skies all.
Okay.